Hi everybody, my name is Erich Morisse. I'm responsible for the cloud and virtualization at Red Hat in the Americas. And today we're going to be talking about some of the value of going to cloud. I do have some product-specific things in here, but you are absolutely welcome to ignore them. The goal is to talk about some particular architectures, see what some folks have done, and actually we'll be pulling some examples from other industries that have helped to really get to scale. So before we start, a couple questions for folks here. How many of you have either been participating in introducing a new technology into your agency, or bless you, or been directly affected one in the past 5 years or so? All right. So for the hands that weren't up, haven't brought in any VMware or changed databases or anything? Yeah, bless you. All right. So quite a number of you. All right. So how many of you have retired technology from your agency within the past 5 years? Good. All right. We got a hand. Fantastic. That's usually more than we're able to get from that. Two. Great. So of you that put your hands up for one or both of those, how many of you found that process to be quick and easy? Yeah. Right. So to your point, it's brutal. Right. So bringing in new technologies can, as much impact as it can have on your operations. The ability to exit them can have just as much or more, especially when you're talking about exiting or retiring a major technology, even if it's a version of a technology that you've upgraded. So what we're going to talk about today in terms of cloud, and in particular in terms of open clouds, is some of that process. And the process for cloud, when it comes down to it, is to make it continually simpler to bring in and to exit technologies that help you adapt to the demands of your constituents. So a little bit of an overview of the things we're going to touch today. So we have about 45 minutes left, and I hope to leave some time at the end for Q&A. So I'll try and get through these slides fairly quickly and take any questions for whatever time you got. So we're going to start with another industry that has successfully embraced scale and done through dramatic change to their operations. We'll talk a little bit about some of the stalling technologies, and we'll talk through three different architectures that we've seen our customers look to implement. And in particular, we'll spend some time focusing on the one that's been most successful. So, all right. So, apologize, but we're gonna start with a quiz. So, Ford revolutionized the car industry. So, December 1st, 1913. You don't really have to know the date, but anybody know what Ford did that revolutionized the car industry? Yeah. Right. Exactly. The assembly line. So Ford is often credited with it, with starting the assembly line. He didn't, right? So it was first talked about with Adam Smith when he was talking about manufacturing pins in 1776 or whatever, right? So, but he's the guy that really brought it to the forefront and really introduced it to technology and to industry and got it going. So the interesting part is, after Ford introduced this, they took 90% of the market. They took everything. Within 10 years, they got crushed. So Chevrolet came out of nowhere, little teeny market share, and demolished them. Any ideas why?
Different colors.
Some of it. So the comment at front was they offered different colors. And that's really a piece of it. So the guy that really got a lot of the mass manufacturing, the assembly line at Ford up and running, had a falling out with Ford, and he went to Chevy. The one big part of the falling out was that he wanted to retool the manufacturing process so that it was designed not to just go after one big thing and do it at grand scale, but make it so that they could actually change the assembly line while it was running. So in essence, they went and they looked back and they optimized the process for building. Not for building a thing, but for building. So it allowed them to relatively quickly, we'll use quickly in quotes here, but relatively quickly be able to incorporate changes into their process and to great effect. So as soon as this came out, they were not only able to serve their current customers by continuing to sell the cars that were served, but they were able to introduce a new car to the market a full year ahead of Chevrolet. So at this point, after this was out for a bit, it was a complete flip. So Chevy then took about 90% of the market, and Ford had to battle back through all kinds of things. So, and at this point, Chevy, because of this process, could offer different colors. All right, so in terms of what we're seeing for technology and talking to our customers, we have had phenomenal success at the operations level with virtualization. Right? So we've seen tremendous success. It's done great things for the economics. We have incredible consolidation. We're able to take advantage of the accelerating Moore's law. So the rapid number of transistors available at the same cost grows exponentially. So we can get more horsepower, more operational horsepower out of what we've had. The hard part is the year-over-year benefit of that is stalling. So here are some numbers from IDC. We are getting rapidly diminishing returns in terms of the continued investment in virtualization. So if you have things that are not virtualized today, go out of your way to virtualize them. If you have things that are already virtualized today, and if your shop has a lot of virtualization, then you need to find what's next in order to be able to continue to take advantage of bringing in new resources. So, clearly it's becoming harder and harder every year. So what are the possibilities? So one is, are we just reaching the amount of capacity, reaching the limits on the amount of capacity that we're bringing into our shops? Or is there just less to learn from these that we can take advantage and provide the value back to our end customers, however you want to define them? So capacity is not the bottleneck, right? So if you look at the amount of horsepower that has been delivered over this same period of time, it's shooting up through the roof. You've got, so if you look at, so the numbers found from last year, there was about a 10-fold difference in that gap between the amount of return or value in the density, the number of VMs per system on average, to the amount of transistors. So while our density is increasing, the efficiency of what we are bringing is rapidly decreasing. That gap is getting bigger and bigger and bigger. So it tells us a few things. So one, and this is the big one, is that we're bringing in capacity far faster than we have a way to utilize it, to harness it and be able to give it back to our consumers. And virtualization very, very clearly is not enough to do that. So we need to talk about the model. And just a little note here. So the Moore's law is for number of transistors. There are very similar ones for the cost of both networking and storage. All right. So if virtualization alone is not enough, what does the alternative look like? So okay. So this is where we got to see all the the fancy results we've seen reported by all of the industry and some of our largest partners. The cost of a VM per hour is about 1/10 on the cloud than it is when you look at the fully loaded cost for running the VM. So that's everything from the hardware and the storage and the people to manage and all the operational side. The server to admin ratios are significantly higher. So we're looking on average of 300 to 1. Folks that spend an awful lot of time with this, such as Google. I saw there was a recent article where somebody looked and kind of did some back of the napkin math, and they estimated Google had about 4,000 to 1. Resource utilization, right? So how do we get the greatest efficiency out of the stuff that we've already bought? We're seeing it about triple for the consumption in the public cloud. Application deployment. So the application deployment in twofold. So one is, how do I get, now I have the bits, and how do I get them out into production significantly faster, but also just kind of the application development lifecycle. We've seen a number of cases with our customers where we help put the power in the hand of the developers to have access to what they need when they need it, and you get a much tighter feedback loop, and we're seeing applications get out significantly faster. So one extreme example, if you look at Amazon, just in their AWS, I think somebody told me they put out about 84 new applications last year. Right, and then okay, so all of those numbers, give or take, are about 10x. Right, we're seeing a huge difference between the impact of what a cloud can do and some of the traditional. So I honestly haven't done the work. If you're interested, I would love to hear from you whether this 10x is coincident, or whether or not that's just that same gap between the virtualization and the amount of resources available. So a lot of work that Red Hat does is it goes and looks at the open source community, but a lot of the open source community is looking at solving problems often in a different way than that they currently are. And Red Hat goes to help define those particular projects. We bring them in, we do an awful lot of engineering, we do an awful lot of contribution, but then we also go through all of the product development cycle that happens after you found the product, right? So what's all the QA? How does it work with all other products? How do you package it and distribute it to the folks that need it? And in essence, we're taking a lot of these pieces and helping to commoditize them. And once things can become a commodity, they're not only less expensive, but it lowers the barrier to being able to consume them. It makes them easy, makes them cheap, makes them usable all over the place. So you'll notice a lot of lineup of, hey, that's a lot of what the cloud was doing. So the goal is to make sure the products are no longer the problem, to make sure that you can go and help your customers, your end users, get what they need, and make things as simple as possible, so your people are freed up to do the work that has the highest impact on your customers, as opposed to a lot of the day-to-day. Okay. So clouds. So pretty much all of the public clouds, with the exception of one that's a bit north of here, run on Linux, and there's a reason for that, right? So and we'll talk about some of the architectures, and we'll talk about some of the pieces that make that significantly easier. And it's got to do with what we first started talking about. Is it's not just solving the problem, it's learning how to build so you can solve the next problems. So when you're looking at scale, and especially, and we talk about enterprises here, but enterprises is really just distinguishing from public cloud providers. IT is really in a tough position. So its users can see everything that is available with the public cloud. They see that it's significantly cheaper, and they expect that sort of service at that cost. The hard part is what they don't see is all the other work that IT does. Is making things repeatable, it's making things supportable, it's helping to implement the standards that help everybody move. But the individual user tends to not see that. So the hard part is a typical enterprise can have hundreds or thousands of different applications that it has to support. And these may be individual silos of capacity, right? So with virtualization, we're getting better at that, to be able to pool across a large set of resources. But cloud helps take a lot of those similar pieces and helps expand it to an order of magnitude or larger to get even more dramatic benefits. So the hard part in terms of the IT budgets is because of a lot of the complexity in what's going on in terms of the new products that are brought in, how to forcing them to work with all the other ones. On average, about 75% of budgets are dedicated to keeping that stuff up and running. And only about 25% of budgets are dedicated to how do we help with the next thing, right? And with the expectations that all of us have put upon us, 25% is a really small amount. My guess is there are relatively few of you people in the room who have had their budgets dramatically increased year over year. If they are, make sure you talk to Dan. He wants to talk to you. But it's a problem, right? So we have all these expectations that are come across us. New projects are always coming out, but most of our budgets are dedicated to keeping the stuff that we already have. So, the hard part about this phrase, the most critical IT decision that's going to be made this decade, is that it's probably not hyperbole. You've got, if you want to be able to take advantage of some of the mass scale, people are going to have to do things differently. What we're going to talk about a little bit, and please come find us afterwards, and we'll be here the rest of the day too, is to help make that transition from what you're doing today to getting to that mass scale as simple as possible. So, 3 choices in how the architecture works. In general, there have been folks who have gone out and said, all right, well, I'm just going to build my cloud from scratch. That's fantastic if you are a service provider. That's fantastic if you are a telco. That's fantastic if you are a public cloud. I have never come across an organization who has had the opportunity to stop their data center for a year or two, throw everything out, and start up from scratch. So that one usually gets dismissed pretty quickly. One of the other directions that we've seen in architecture is, okay, we're going to carve off something new. We're going to take a portion of our IT environment and we're going to convert it to cloud. So general suggestions, you build a cloud out of 20 to 30% of your virtualization servers, ignore the rest of your IT investment, and now that piece is just forever closed off, and you're not able to bring those resources into the larger flow of the cloud. So bad approach over the long run. Short term, great. I know a lot of us are under the gun to say we have provided a cloud to our end customers. The hard part is that limits your ability to go to what's next. Right? So from Red Hat's perspective, we want to help you, but we want you to build an open hybrid cloud. Right? So it's taking advantage of all of your resources and helping be able to, when desired, be able to go out to public clouds. Couple benefits to this. One is particularly you are leveraging your existing investments. You don't have to go for the tear down approach and start up new, and you're making a cloud out of what you've already had. So when we talk about this, a lot of what we talk about is an open hybrid cloud, and there are a lot of similarities to open source. So we'll talk through some of the benefits and some of the characteristics you should be looking for and asking your vendors about when you're considering your architectures. So certainly open source. There is, it's no coincidence that the largest public clouds are built on open source in terms of the velocity of innovation, in terms of being able to to enforce your own control and be able to get that from usually multiple vendors to help with that strategy as well. You have to have there has to be an independent community. So one of the things that we look at with Red Hat, whether or not we're going to be involved with an open source project, is what the community looks like. So for all the projects we're going to talk about today, we invest very heavily. We have all of our code is either open source or in the process of being open sourced, if it's an acquisition, and the people around it are what really help grow. So I think it was Joy at Sun who said something really smart that resonated with me. And he said there are an awful lot of really smart people working at Sun, but there are more smart people that are not. Right, and that's the value of community. So it is part of, it is not only of, hey, we think we know what is the best for our customers after having the conversations with working with them, But, there are an awful lot of ideas and everything from, just the operational mode to, hey, I was trying to figure out this one thing on the side. Somebody else that may not have the connection directly back into be able to provide an RFE or a request in the company to get something fixed. They fix it or put the idea, get the community, and everybody takes advantage of it. So, open standards. So this is absolutely critical when you're considering your architectures. So so a lot of budgets. Most IT budgets that I've seen are somewhere about 4-to-1 operations to CapEx. So about 4-to-1 people and process to stuff you've purchased. What that means is for every dollar that you spent on putting something in your data center, you're spending $4 on training people and getting the process to keep them running. So it can be even harder on the process side than on the technology side to make any changes. With open standards, the ability to change those technologies while reducing the impact on your people in terms of learning, retraining, etc., the impact can be dramatically reduced. So freedom to use the IP, so not a lot of surprise there. Yeah, hi, question.
So one of the discussion points that our management has is, going with open source is less expensive at the front end, but at the back end with the labor and the training, et cetera, is more expensive than going to some closed architecture solution from a vendor that is, here's the product, here's the interface, it's all GUI, here's this really nice interface and the management console. You guys can learn it in 8 hours.
Right. It's a good question. So the question was, we've been seeing information and talking about the difference between the cost of supporting open source versus the cost of supporting a traditional proprietary vendor. So I guess there's no one-size-fits-all answer to that. I mean, a lot of it has to do with how you're consuming the open source software. Red Hat's model is to take open source software and be able to provide it through that exact same method that you're used to with the other vendors. So, responsible for all of the support, all of maintaining the common interfaces across things and being able to help reduce a lot of that. I'd be happy to talk to you more about it after, especially if you got some specific examples. I'd be happy to go through them. Okay, well, so that talked a little bit about some of the open APIs, but also to portability, right? So if you have an application and you want to be able to use it across multiple architectures, the most common way to do that is open source. So one of the things that we've done for all our products in the cloud is to make sure that they are loosely coupled. While I would love to say every single one of our customers use every single thing that they have from us, and they use it all in the stack and they use it this way, it doesn't happen, right? Everybody's got different use cases. They may have, right? So they've got a relationship with a vendor, and the license is going for a few more years, but they have this other piece that they want to bring. When you're thinking about the architectures, it is strongly recommended to be able to loosely couple all of the components. This loose coupling through some of the things that we were talking about on the previous slide, through APIs, through open standards, allows you to be able to pull in and switch out the technologies significantly faster and have lower impact on operations and thus on cost. So pause there for a moment. We'll talk a little bit about some of the things that we've done with the architecture of some of our technologies. And go through some examples. Any questions about any things we've talked about so far? Great. Okay. So a lot of what we've seen, everybody said, all right, fantastic, I have to build a cloud. I have a whole bunch of physical servers. I've got a ton of virtualization, and I'm trying to figure out how to get to what's next. So cloud is often looked at as the next evolutionary step beyond virtualization, although it, depending on how it's implemented, can have some very different operational sides. one of the common technologies that is beginning to be talked about a lot and beginning to be deployed is around OpenStack, right? So phenomenal scale, incredibly different operating model and expectations on users and what the technology is than virtualization. So, for example, you want HA, doesn't support HA. You want to be able to pick where you want the workload to launch. Significantly harder to do that. So traditional IT service, traditionally based mainly on physical and bare metal systems. Over the past decade, we've seen the rapid adoption of virtualization in some form or fashion to help to drive a lot of the efficiency of the use of their servers. The next evolution is towards the cloud-based operating model to be able to continue to deliver service, that same IT as a service, and be able to put more power in the hands of the end users. So the hard part is, great, I'm putting more power in the end users, but my users are crazy. They do absolutely anything. They go around me every opportunity they have. I'm sure you guys have never had this problem, which is fantastic. But fun things like, all right, developer built a new application and sends it over to your QA guys and say, fantastic, I need to push this out. And I said, okay, well, this doesn't look anything like the standard build we've had. Said, oh yeah, well, I added a few things I found from the internet. Like, all right, well, where did you find them? So I already told you I found them on the internet. Right, so incredible implications on supportability, not to mention security and everything else. Right, so the goal is, how do you get to balance the benefits for both? How do you be able to put more power in in your end users to get them to be able to participate in what they want without removing any of the control? So how do you get the architectures and the things that you have certified, that you've engineered, that work, that work with your backup, that work with your identity management, that work with your security policy, and work with everything else, and still be able to provision that quickly? So, a lot of So a lot of the questions that we see, right? So today we want to be able to quickly meet all of the infrastructure demands of our users. Is that actually going to make things harder for IT? It can be complex. We're adding another layer of abstraction. What does this mean? Is it more vendors? What's the process? What's the impact? So I've already got enough silos of infrastructure that I have to manage. Is cloud going to be another silo, and is it going to make it one more thing that I have to take care of? So application management, very complex. If I now have to do this in the cloud, and I've got to worry about A, all the complexities of the cloud, but B, because there's abstraction, maybe my users have less information about where things are going, what's going to be the impact on latency or bandwidth between different systems that are making up in the architecture. And then maintaining control, security, and compliance. So if I have all of these pieces, so I'm putting them there on my private cloud, I understand that piece pretty well. If I want to be able to start to take advantage of some of the scalability and other things that are afforded to me through consumption of private cloud, what does that do for all of the above? Does it magnify it? It's a completely different vendor and all these pieces. So let's talk a little bit about bringing all of these together. So CloudForms, which is one of our technologies, looks at these in across three different pieces. So it's not important that CloudForms does it, but think about it in terms of the architecture and think through the questions that you're going to be asking as you go through it. So one is, how do I build the cloud? What's the infrastructure that I want to lay down? Am I taking advantage of the that I already have in place? Am I putting in a new farm? And do I want to be able to take advantage of somebody else's cloud, whether it's a public cloud or somebody else is hosting a private cloud for me offsite? Great. So then you've got the infrastructure pieces. The other pieces are, some people look at cloud as kind of a panacea. Fantastic, we'll push everything out, and then we don't have to worry about anything ever again. So cloud, as much as I'd like it to be that, it's a pretty long way from that. You still have to go, you still have to worry about, and you still have to consider all of the things that you're doing in your traditional IT in terms of governance. What is it, what are the packages that have to be there? What's my update model? How do I make sure things are up to date? How do I make sure that people have access to this? How do I troubleshoot? And finally, the one piece is, all right, the piece that usually gets talked about most, maybe because it's the easiest, is just the provisioning to a cloud. So if I want to request the new server, fantastic. What do I want to put on that server? Is it just a Windows box or just a Red Hat box? So okay, well that's nice, but that's not going to help too much. I also need probably an application on top of it. I then have to configure that application in that VM to be able to talk back to all of the pieces that are help run the data center. So connect back to the connect back to your backup, connect back to say a database or your identity server. And all of these may be very different depending on where the things get provisioned. So if you're launching a new web application up in Amazon, it's probably going to have a very different security policy than if it is behind your firewall in your data center for an internal use application. So one of the things that we look at is there a way to be able to manage across multiple types of resources and be able to do so with a common view, right? So CloudForms is able to connect to different types of cloud technology, including virtualization. So the three pieces that we support today are VMware, Red Hat's enterprise virtualization, so our own virtualization, as well as Amazon EC2, and we will be having we'll have connectivity and support for more types. One of the things that we've found in a lot of the conversations with customers is we talk about hybrid cloud. The term originated just talking about, okay, I want to have a public cloud and I want to have a private cloud. What we're seeing it very rapidly turn into is I need to be able to provide a cloud that supports multiple types of technologies. And they may be within a data center, they may be across data centers, and they may be in between a combination of public and private, but they're definitely having to support multiple technologies. So as you think about your process, think about tools that you can use and find to help be able to stretch and take advantage of all of the technologies you have today, as well as being able to get this across the next 2, 3, 5, 10 different resources that we're seeing. I mean, and just in the public cloud market, we're starting to see some, we're beginning to see some differentiation in the types of services that are offered. So you have, Amazon, which is the very big, low-cost provider. So they're very low touch. You do whatever you want with it. If it breaks, well, fire up another server and try again. And you start to see Rackspace, which is beginning to differentiate that. Their motto is in the really high service touch and their fanatical support. So they are more expensive than Amazon, but they also provide the support. So starting to see the value of a stretch between multiple types. So I think that is going to continue to exaggerate. Where the shakeout's going to be a few very large low-cost providers. And we'll start to see people differentiate themselves on things like service, such as some coming from the managed hosting providers like Rackspace, and we'll probably start to increasingly see a number of niche markets as well, serving some small things. And what we're talking to a lot of our customers are making sure that the architectures that they're developing are able to support the multiple technologies so that they can move when the need changes. So, being able to manage the application lifecycle. We saw a huge jump in the number of servers, and I'll use that one in quotes, with the introduction of VM, with VMware and virtualization. It's a huge number of the growth of VM. So we were talking about server sprawl. We're bringing virtualization to be able to consolidate. Well, guess what? Now virtualization makes it significantly easier to deploy a new machine, so now we've got VM sprawl, right? What are we going to do to combat VM sprawl? All right, we got cloud. Well, guess what? Cloud's going to help with that, but it's also going to make it significantly easier to deploy everything, so we'll probably see even more, right? So one of the things to keep in mind is what are we doing for all of the bits that we have on the servers? How do we think about it as a continuous life cycle of maintenance, of updates, of patches, and patches for everything from fixing security posture to making sure that we've got the the latest features that are going to be able to add more functionality and support and speed to the applications that are already out there. So when you're considering how you want to work with the cloud and how you want to work in terms of applications, and those applications can be everything from web servers to your backup systems or everything else they use internally. Think about them over the complete life cycle of the initial deployment, of the publication of that information. How do we get it deployed? Is that system going to be deployed configured initially? Are you going to lay out that VM and then put the applications on top of it? And how do you manage it over time? So certainly some benefits to each. One of the ways that we're seeing folks work with the cloud forums is to do it in an incremental approach. So starting off and building, here's what I want a VM to look like, have that and be able to publish that to all of the clouds and technologies. After the VMs are out for a while, doing some surveys of their customers and saying, all right, what are some of the top applications that are in use? So one example is it may be a web application. So it's a combination of a web server, application server, and database, and one or more of each of those pieces. Okay. So then being able to offer those up as individual services to be able to reduce the time to get any of those out. And then, continually going through the process to see what are the current applications and what are the pieces that we can put in the hands of people faster. So the third step in that is to be able to offer an entire environment through a self-service portal as opposed to just individual VMs. So the initial, that web application standard one may be, all right, so 5 web servers, 1 application server, and database server, rather than going through the 10, 15, 100 tickets it takes to request all the individual VMs, get the application software installed, get the application server configured, and then get them all to talk to each other. Be able to offer those up as a single unit that auto-configures at the instantiation time. So talked about it in terms of, so we'll go through this one quickly, but just talking about it in terms of the application lifecycle. So one of the hard parts about managing a VM as an image is everybody tries to get to a golden image. It never lasts long, right? So somebody wants one additional configuration file, some other tweak, and then you have 2 images that are 99.99% the same in terms of bits, but have to be managed completely separately. So, and if you magnify that by supporting the multiple different technologies that you're going to be supporting for virtualization, then it becomes even more difficult, right? So if you're supporting 3 different ones and you've got 2 gold images, okay, fantastic. You've got 6 different images that you have to manage, and they're almost all the same. So look for methods in your application lifecycle management to be able to manage those as a single unit. So if you're interested in some of the recipe-based stuff that we've done to be able to get to that, I'd be glad to talk to you about it. Okay. And really just making sure we mention the self-service. So with that VM, so with the server sprawl, the VM sprawl, to probably going to see cloud sprawl, that governance model becomes significantly more important. So what are you doing to be able to ensure that all your users have the latest patches? As you hand over control to systems, are people installing stuff that you don't want there? And because of the expected growth and jump in terms of the size and numbers of systems that we're going to see, it is far more important that you be able to automate a big chunk of that. than you do today. So I said I want to leave some time for questions, so I'll wrap up here and we'll be able to take it from there. So here are the four kind of conundrums I posed to you earlier around the infrastructure and the applications and management. There are a lot of things that you can do to help combat all of those and actually make it significantly easier even than you have it today. But if I can offer, one piece of kind of parting advice as you begin to roll out your own cloud architectures, is don't try to do everything when you start. Look at it as something like an 80-20 rule. Figure out what problems you're trying to solve for your customers. Solve 80% of it. And so start with just offering VMs, then work to applications, and then work to application environments is just one example. But always, so once you've conquered that 80%, then look for the, what's the 80% of that 20% that remains, and be able to do it in an iterative approach. If you can boil it down to some significant steps that show value early on, you'll get better traction from your customers. You will be able to get more funding to help them do the right things, and you'll it will grow from there. So, thanks. So.
Any questions before we close out?
Hey, Eric, sorry to ask a Red Hat question, the Red Hat version, but I've had a couple of departments actually suggest like a POC.
Mm-hmm.
Do you recommend that type of setup for an initial looking at kind of configuring a cloud to provide services to constituents? Do you think a POC, something like that, would be a good benefit to see how effective it might be?
So the question is, is there any benefit, and if so, what's the benefit of doing a proof of concept before jumping into the technology? You can probably guess by the way I phrased that I'm a little bit biased towards I think it's a great idea to do a POC. This could be the introduction of a lot of new technology. I think it's important to get your hands on it, to understand the way it works. A lot of the cloud technologies now are really focusing on the kind of the orchestration of getting a bunch of things to work together. So make sure you know which things they are that you want to work together, and start talking to whoever your vendor is about what could the potential impact be on your users. What are the direct benefits, and start to show them early. I mean that's another good point is if through the POC, if you have the opportunity to start talking through what it can do with some of your early adopters, it's a great way to show them what you're looking to do for them as well.
Anybody else?
All right, going once. Thanks everybody.
Thank you.